Alright, geometric series. As you remember from yesterday, the series is just the sum of a sequence. So what we're going to do today is we're going to work with geometric sequences and find their sum. So if we let A1, A2, A3, all the way up to AN be a finite geometric sequence, finite is important, it has an ending point with R not equal to 0, or sorry, R not equal to 1. Then the geometric sequence or series has a summation notation of the sum from k equals 1 to n of ak equals a1, which is our initial term, times 1 minus r to the n power divided by 1 minus r. Remember, r is our common ratio, and a1 is our initial value, and n represents our ending value. Okay? So let's try a couple examples. In example number 1, we have the sum from n equals 1 to k of 8 times 2 to the n minus 1 power. Alright, first of all, we need to determine our initial value of this sequence. Alright, our initial value is going to be 8 because when we plug in 1, we have 2 to the 0 power, which is 1, and 1 times 8 is 8. So our A1 value is going to be 8. So we're going to have 8 times 1 minus our common ratio, which is 2 in this case. And we're going to take that to the 10th power and divide it by 1 minus 2. And all you're going to do is just simplify or plug all that into your calculator, and you should get 8,184. Okay. Alright, another example that we can try is if we have the sum from n equals 1 to 6 of 3 times 4 to the n minus 1 power. Again, our initial value here is going to be 3 because if we plug in 1, we would have 4 to the 0 power, which is 1. So our initial value is 3, and we take 3 times 1 minus our common ratio, which is 4, to the 6th power, all over 1 minus 4. Okay. You're simply going to plug this into your calculator and you will get 4,095. Alright, why don't you try example number 3 and 4. For both example 3 and 4, you will get decimal values. Okay? Okay, now since we talked about the finite series, we now need to talk about what happens when we have an infinite geometric series. Alright, so the infinite part is important. Remember, the infinite series means it goes from 1 to infinity. Okay, so if we have the sum from 1 to infinity of ak, that is going to be equivalent to a1, our initial value, over 1 minus r. It's important to remember that our common ratio, the absolute value of r, has to be less than 1 in infinite geometric series for us to find a sum. If it is greater than or equal to 1, the series diverges and there will be no sum. This is important. Make sure you make note of both of these situations. So when we're doing these, it's important that you always look at your r value first to determine whether you need to plug it into the formula or not. Alright, so in our first case, our r value is 0.6. Now, since 0.6 is less than 1, we are okay and we can go ahead with this example. Okay, so we're just going to plug everything we know into our equation above. So our initial value is 4, and then we have 1 minus 0.6. Well, when we plug that into our calculator and simplify that, we are going to get 10. So the sum, as this series goes on infinitely, we'll get 10. Okay. In example 2, our r value is 1/2, and 1/2 is less than 1, so we are good. And then we're just going to plug it into the above equation there. We're going to take 100, our initial value, divided by 1 minus 1/2, and that's going to give us 200. Okay. All right. At the bottom are 2 additional examples. These are going to be for finite geometric series. We are asked to find the sum of the first 11 terms. These are just 2 additional examples for this section here. All right. So in the first one, you're given the sequence 6, -3, 3/2, -3/4, and you are asked to find the first 11 terms. All right. So first of all, what you want to do is we know our A1 is 6, and then we need to determine our common ratio. Okay. So A1 is 6. And our common ratio equals -1/2. Okay? So now that we know that, we're just going to simply plug it into our finite geometric series summation. Okay? So we're going to take our first term, 6, and we're going to multiply it by 1 minus our common ratio of -1/2. And we want to find the first 11 terms. So we're going to take that to the 11th power, and then we're going to divide that by 1 minus r. Okay? Once you have determined where your values go, then you just plug it into your calculator and you should get 4.002. Remember, we always round to 3 decimals. All right, number 4. Number 4 is a little bit different because in number 4 they give you the summation between 5, 15, 45, and 98,415. Please note that this is one term, one value. Okay, so we don't know what our nth, we know what our nth term is, but we don't know what n is. So that's our first step. And to figure out what n is, we're going to first find what our common ratio is. So between these terms, each time we're multiplying by 3. So our common ratio is going to be 3. And our A1 value is going to be 5. Okay? So once we have that, we can write our geometric sequence explicitly. We can say, all right, AN has to equal 5 times 3 to the n minus 1 power. All right, so once we're at this point, we can go ahead and say, well, solve for n by plugging in 98,415 is going to equal 5 times 3 to the n minus 1 power. From here, we're just going to do some algebra. We're going to first divide by 5. And once we divide by 5, we get 19,683 equals 3 to the n minus 1. And then we're going to use our logs. So a couple different ways we can say log base 3 of 19,683 equals n minus 1. Oops. And then simply using our change of base formula, we can do the log of 19,683 divided by the log of 3, and that is going to give us 9. So 9 equals n minus 1. And then we just add 1, so n is 10. Alright, so once you, So once you are at that point, we know what our n value is, which is our last value. We can go ahead and use our finite geometric series. And we can say, all right, the sum from k equals 1 to 10 is going to be of 5 times 3 to the k minus 1 is going to be equal to 5 times 1 minus 3 to the 10 over 1 minus 3. When you plug all of that into your calculator, you're going to get 147,620.